This is the worksheet on chapter 14.3, which was on the coefficient of determination. So again, we have a bunch of fill in the blanks questions first to test our understanding of the remember those three quantities we learned, which were the SST, SSR, and SST, SSR, and the SSE. All right. So let's go through this. It says a measure of total variation in the observed values of the response variable. The total variation in the observed variables of the response variable. Again, response variable, keep in mind, is the y variable, is the total sum of squares. Total sum of squares. The mathematical abbreviation for it is SST. All right. And the equation for SST using the defining formula is a sigma y minus y bar squared. All right. So that's the equation for total sum of squares. All right. Then we have a measure of the amount of variation in the observed values of the response variable explained by the regression. This one is the SSR, or the regression sum of squares. All right. Regression sum of squares. The mathematical abbreviation for it is SSR. And then we have a measure of the amount of variation in the observed values of the response variable. Now, I need to make a correction over here to the statement. A measure of the amount of variation in the observed values of the response variable not explained, this should be not explained, by the regression is the SSE, or the error sum of squares. Error sum of squares. And the mathematical abbreviation is SSE. Okay, so this was just checking our knowledge of the three quantities that we use to find the coefficient of determination, SST, SSR, and SSE. Question number 4 says, for a regression analysis, SST is given as 8291.0 and SSR equals 7626.6. Obtain and interpret the coefficient of determination. So, coefficient of determination is given by the formula, is expressed by the notation R squared. And the formula for it is SSR over SST. Now, they've already given us the values of SSR and SST. All we need to do is plug it into this equation and do the calculation. So SSR is 7626.6 and SST is 8291.0. So it's going to give us an approximate ratio of 0.9199. All right, and then it says interpret. The way you're going to interpret is 91.99% of the variation in the observed values of the response variables, values of the y variable or of the response variables explained by the regression response variable is explained by the regression. Okay, by the regression. Now, the fact that R squared is a value close to 1, that means that the regression equation is extremely useful for making prediction. All right, so r squared, and that should be a small r squared being close to 1 for this example, close to 1 implies that the regression equation is rather useful or very useful in making predictions. All right, so it's a pretty good equation, whatever equation it relates to. Part B says determine SSE. Now, they've only given us SST and SSR, so we have to find SSE from these values. But keep in mind there is an identity which goes SST equals SSR plus SSE. All right, so we know the value of SST is 8291.0, SSR is 7626.6. We need to find what SSE is. So just solve for SSE. So we'll get a value for SSE, which is 8291.0 minus, you're right, you have to move the 7626 over to the other side to solve for SSE. So it's 7626.6, which for a value of 664.4, and that's the SSE value. All right, so we can find, if you know your SSR, if you know SST, finding SSE is very simple. All right, now the next problem in the worksheet is to calculate the coefficient of determination using the defining formulas. So this is the data given to us, and this is the equation from this data. So let's try to figure out how to find r squared from it. Again, we'll work through the table. So we need to find SST, SSR, and SSE. That's what we initially have to find. And once we have these values, we can find r squared. Now, we don't really need SSE for coefficient of determination, but it's easy to find the SSE if we know the values of SST and SSR. So let's start here. The first two columns, we begin by writing whatever x and y values are given to us, right? So for the x values, it's 2, 4, and 3. For the y values, corresponding y values, 2 and 3, and then 5, and then 7. The y hat values come from this equation. You have to plug in the values of x and do the calculation to come up with the y hat value. So x, the first value is a 2. So 2 plus 2 is 4. You have to plug in the 2 into the x. Next one, x is a 4. So 4 plus 2 is 6. And then we have 3. Again, all go into x. So 2 plus 3 is a 5. So now we got our y hat values. Now we'll do the subtractions. All right. So y minus y bar, that will give us the SST value when we square and sum it. So y minus y bar, however, we don't have y bar, right? We have to do the calculation. Y bar and y hat are not the same thing. Y bar is the mean of all the y values, right? So let's add up. How do you find the mean of the y values? Again, the formula for mean is sigma y over n. So sum of all your y values, 7 plus 3, 10 plus 5, 15, divided by 3 is 5. So our y hat value is a 5 here. Okay, so now we can do the subtraction. Y minus y bar, not y hat. That's for SSR, all right? For SST, it's y minus y bar. So 3 minus 5, negative 2. 5 minus 5 is a 0. 7 minus 5 is a 2, right? And now square it. Minus 2 whole squared is a 4. 0 squared is a 0. 2 squared is a 4. Right? And then sum them up. So 4 plus 4 plus 0 is an 8. So the sum is 8. Correct? It's 8. And what this 8, it's SST. This is what SST is, total sum of squares. Now we'll go on to the next two columns, which is for finding SSR. Now this time it says y hat minus y bar. Now y bar is the same, it's 5. So now we will take the y hat column and subtract 5 from those values. So 4 minus 5, negative 1. 6 minus 5 is a positive 1, and 5 minus 5 is a 0. You have to square it. So minus 1 squared, whole squared is a 1, 1 squared is a 1, 0. So it's 2, all right? And that's your SSR, the sum of y hat minus y bars whole squared is SSR, which has a value of 2. And then the final one is to find SSE. So we are going to do the calculation, all right, through the table for SSE, and then we are going to cross-check using the identity. So y minus y hat, it's 3 minus 4, which is negative 1. 5 minus 6 is also a negative 1. 7 minus 5 is a positive 2. Square them in the last column. So 1, 1, and 4. 4 plus 1 plus 1 is a 6. So sigma is 6, and that represents our SSE. And you can already verify here SST minus SSR should be equal to minus SSR should be equal to SSE. Or you can look at it as SSR plus SSE equals SST, which is correct, right? 8 minus 2 is a 6. All right, if you do 6 plus 2, you should get 8, which is also correct. Okay, so now we have our value for SST, which is this value here, right? So that's 8. And we'd have our value for SSR, which is a 2, this value here. And for SSE, it's 6. So we verified our, sorry about that. Let me just try to erase this and write again. All right, it's all over the place. So SSE, that was a 6. Okay, verify the regression identity. It's 8 equals 6 plus 2, so that's verified. What else? Now we have to compute the coefficient of determination. So coefficient of determination, let me just move it up a little bit. So coefficient of determination denoted by R squared is SSR over SST. So SSR was 2, SST was 8. So 2 divided by 8 is 1/4, which is 0.25. R squared is 0.25. So looking at this value, it's clear that it's not close to 1, and therefore this equation, whatever this equation is pertaining to this data set, is not going to be a useful regression equation for making predictions. All right, so that's how we answer these questions. Now over here, part D says determine the percentage of variation in the observed values of the response variable. That is explained by the regression. All you have to do is convert your 0.25 to percentage by multiplying by 100 and say 25% of the variation of the variation in the observed values of the response variable. In the observed values of the response variable is explained by the regression equation. All right. Okay, so I think the next question is about doing the same calculation using the computing formula. Now, the last part of the question was asking, state how useful the regression equation appears to be for making predictions. Of course, we already said that it's not going to be a very useful equation for making predictions because the r squared value is not close to 1. So you can say since r squared is 0.25 and is not close to 1, the equation will not be useful in making predictions. Will not be useful in making predictions. Okay, so now we can go to the next question, which is finding the same r squared value using the computing formula. Again, the data set is also the same, so we just have to see that we get the same r squared value using a different method, which is the computing formula. Again, computing formula is supposed to be a lot more efficient and faster. So let's see if that is the case. Remember, over here we had to do a lot of subtractions. We had to find the mean of all the y values. Then we had to do a lot of subtractions and then squaring and then adding. Let's see what is involved here this time using the computing formula. So again, same equation and same data set. So I'm going to write my x and y values 2, 3, 4 and 5 and 3 and 7, right? Those were our x values. Now in the third column, all we do is multiply our x and y values. We are using the computing formula this time, right? So 2 times 3 is 6, 5 times 4 is 20, and 7 times 3 is 21. So we sum them up, right? Sigma xy is going to be 21 plus 20, 41 plus 6, 47. All right, we also need to sum up x and y though, so let's do that. Sigma x is 2 plus 4, 6 plus 3, 9. Sigma y is 7 plus 3, 10 plus 5, 15. And then we have to square. In this fourth column, we have to square up all our x values and then add them. So 2 squared is a 4, 4 squared is a 16, 3 squared is a 9. So when we add this up, we should come up with sigma x squared equals 16 plus 4, 20 plus 9, 29. And we have to now, in the last column, we have to square our y values and then add them up, sum them up. So the y values would be 3 squared, 9, 5 squared, 25, 7 squared, 49, and we come up with a sigma y squared value of 83. All right. So here we have our values. Oops, this is again floating around. So let me just redo this one more time. Just the last column. It's 25. Then we have 49 for a summed up y squared value of 83. All right. So I'm going to write all the summed up values again here. So it's in front of me when I plug into the equation. 15x times y sigma is 47, sigma x squared is 29, and sigma y squared is 83. Now, here are our SSR. Okay, I don't know why this keeps happening every time, but 47, 29, and 83. Hopefully, it'll stay now and not jump around. All right, so the formula for SST using the computing formula is sigma y squared minus sigma y whole squared divided by n. All right, so let's plug in the value. Sigma y squared is 83, right? So it's going to be 83 minus sigma y is 15. So, but you have to square it, divided by n is 3, right? We had 3 values of x and y. So 15 squared divided by 3. So when you do this calculation, you should come up with 83 minus 15 squared is 225 divided by 3, which should give you a value of 225 divided by 3 is 75. All right, so it's going to get 83 minus 75, which is 8. So the value of SST is 8. And if you remember, we had got the same value using the defining formula. SST was 8. SSR using the defining formula was a 2. So let's see if we get the same answer here. Sigma x times y. Let's plug in the value. Sigma x times y is 47. Minus sigma x is 9. Okay, I'm back now. I lost the page for a moment. So for SSR, we are in the calculation of SSR now. Sigma x times y is 47 minus sigma x is, where's sigma x? 9 times sigma y is 15 divided by n is 3, but keep in mind you have to square the entire numerator, all right? Divided by S sub xx is sigma x squared, which is 29, minus sigma x is 9 squared, divided by 3, all right? So 47, let's work the numerator first. 47 minus 9 times 15 is 135, divided by 3 whole squared. And then in the denominator, we have 29 minus 27. All right, 9 squared is 81. Let me write that down anyway. 81 divided by 3. So we will have here 47 minus 135 divided by 3 is 45. So 45 squared divided by 29 minus 27. So let's continue. 47 minus 45 squared is 2 squared in the numerator. And 29 minus 27 is a 2. So it's 4 divided by 2, which gives us a 2. And that's the exact value we got finding the SSR using the defining formula. So SSR is also equal to 2. And SSE, you can just subtract 2 from 8 and get your SSE value. Use the identity, right? So it's going to be SSE is going to be 8 minus 2, which is equal to 6. All right, so this is how you're going to use the computing formula to calculate the R squared value. We didn't calculate the R squared value, right? We just found the three sums of squares. So SSR squared is going to be SSR over SST. SSR is 2, SST is 8, so which gives us 0.25 for an answer, whatever we got using the defining formula. All right, so that completes 14.3, the worksheet on 14.3. We have one more worksheet on this chapter, 14.4, which will be on correlation coefficients.